Hello, grade 12s. Okay, so today we're going on to similar triangles. We're going to be working from the slides 1 to 14, and this is a separate PowerPoint. It's number 2, proportionality geometry. Okay, so before we go on to any of these examples and stuff like that, I just want to remind you what similarity is. A similarity means that the triangles they look exactly the same, except one is bigger or smaller than the other. So all the angles will be the same, but the lengths of the sides will be different, but they will be in the same proportion. So for example, you take a small triangle and you double the size, so the proportion there would be 2. Each side is doubled, but all the angles are still the same. So you remember how we prove similarity, and I think this goes back to grade 9. There's 2 ways that we can do it. The first way is we can prove that all 3 angles are the same. And the second one is if you can prove that the sides are in proportion. In other words, like I used that doubling the sides. So if you can prove that all sides have been doubled, there you have that proportion. Okay, so that's what the first couple of slides are talking about. They're just reminding you that it's angle, angle, angle. And the next one is if the sides are in proportion. And then we've got a couple of proofs there for these things. So what I'm going to do is I'm going to go through a very simple example. This is not in your slides. So just to show you how we do this. So what I want to do here is I want to prove that this triangle ADE is similar to the triangle ABC. Okay. So what I say is I say in triangle ABC, the big one, and triangle, let's do the smaller one, ADE. What I need is I need 3 angles to prove. Okay, so the first thing I can see is in the big one, ABC, and the smaller one, ADE, we have this angle A that is common. So angle A is equal to angle A, and that is common. Right. The next thing I can see that this angle D1 would be equal to angle B because we have corresponding angles. Those are parallel. So angle D1 is in the smaller one, so that will be on that side. And angle B is in the bigger one, so that will be on that side. So we get B, angle B, is equal to angle D1. And we have corresponding angles, and the lines that were parallel were DE, parallel BC. Okay, now for this one, what I can do is I can say automatically that C is equal to E1, the third angle of the triangle. But I'm not going to do that for that one because I can see that I have parallel lines again. So I'm going to say that angle C is equal to angle E1, corresponding angles. And the lines that were parallel were DE, parallel BC. Okay, so therefore, and what I do is I read it down like this, grade 12s. So triangle ABC, similar to triangle ADE. Okay, that's important reading it down like that, because you have to get your proportions the same. And I'll show you that now. And our reason for this was angle, angle, angle. Okay, so now you're probably asking, well, why are we proving that these things are similar when we're dealing with proportionality? Because we can get our proportions out now. So what I do is I say AB over AD. So we have AB over AD will be equal to BC over DE. BC over DE is equal to AC over AE. AC over AE. And my reason for this is similar triangles. Okay, and that is why it's important to read it down like this when you read out your statement over here. Okay, so you can see here we have AB over AD will be BC over DE, which will be equal to AC over AE. All right, so let's go on to now their example. So we have example 1. They're saying to us that given A1, this angle over here, is equal to angle C. Prove that triangle PAD is similar to triangle PCB. So that we want to prove that the smaller one is similar to the bigger one. Okay, so what I say is in triangle, let's do PAD, and triangle PCB. Okay, we need to prove 3 things. Okay, so the first thing I'm going to say is angle P is equal to angle P, because it's an angle that is common with both those triangles. So we have angle P is equal to angle P, and it's common. The next one I'm going to say is angle A1 is equal to C2. Okay, so we have to just check here. So we've got A1 is in triangle PAD. So that's going to go on this side here. So we've got angle A1 is equal to angle C from the bigger triangle, and that was given to us. So if you have a look here, we've got this angle with this angle, and we've got this common one here. So we just need the third one, which would be D1 and B. So D1 is in the smaller triangle PAD. So we've got angle D1 is equal to angle B from the bigger triangle. Now, there's no clear reason why that would be equal to that. Just for the simple fact that we've got 2 sets of angles that are equal already. Therefore, these must be equal because we have interior angles of a triangle, or third angle of a triangle. Okay, so therefore, and I'm going to read it down as it's like this. So we have triangle PAD similar to triangle PCB. And my reason for that is angle, angle, angle. Then you can see from this, we can get our little ratios coming out. I know it's not part of the question, but I just want to show you how we would do it. So we get PA over PC is equal to AD over CB, which is equal to PD over PB. Okay, and a reason for this, similar triangles. All right, grade 12, stick around for video 2, please.